Hello everyone, it's Lihan Chu or Chu Lihan here. Someone may know me as IT Chu. And so today I will want to talk about Ethereum Foundation Small Project Grant. This video will start with summary on problem and why it matters. The summary will then go through proposed solution, reachable roadmap and future roadmap. After going through all the summaries, there will be detailed explanations on each part. If I think the part does not need further explanations, the specified part will be skipped. There will obviously be things that I don't consider or this project may not really suit for applying grant. In that regard, I do want to apologize in advance. This video will also be made in bilingual, English and Chinese as some sorts of information sharing. Regardless of any hierarchical type of CA models, MITM is considered to be an issue which until this date may not be fully solvable. While there may be some sorts of traceability with proprietary or open source CAs, from an external viewpoint, it still have two main MITM issues. The first issue can't exactly be solved unless the user consists of full CA infrastructure within its premise. This is an issue whereby there could be a government acting as man in the middle before the said certificate or public keys or relevant information reaching CAs. The second issue is that there's no direct ways to contact with CA provider in verifying the certs that were issued by the CA. For these two issues, it requires a safer way to be able to verify to reduce MITM attacks. For such a way to work, it needs to involve with some sort of identity and then verify accordingly. At the least, we have seen it being used in WhatsApp or Signal's secure messenger. The way that WhatsApp or Signal sender and recipient verifying with each other in an offline manner, that is called out-of-band communication. In an organization that is having its own infrastructure, it can do such verification easily. However, repeatedly doing such a verification is troublesome and may not be feasible at all times. The initial verification must be done in an offline manner, but the verification afterwards can be done in an online or remote manner. The remote manner here refers to can be used in email communications or any messaging functions provided by any apps such as Discord or Session Messenger. This saves some troubles. The mechanism being used is some sort of something we have. The technical jargon for the mechanism is challenge and response mechanism with digital signature as its core. It works like the following. When I use the word server, it can also be interchanged with users. This approach is zero trust by default to an extent. It can also reduce an extent of MITM attacks. In situations whereby there's no control over infrastructure, at the least, this kind of approach and recognizing the submitted public key, allowing users to verify with each other. However, whether there is a reduction of possible MITM attacks are not known in such a case. In most programming languages, there are two main types of data types. The first type is mutable data type. The second type is immutable data type. For programming or coding folks, immutable data types mainly consist of objects, integer, double, float, char, string. Mutable data type mainly consists of arrays and pointers. While in school, to talk about this information, they don't seem to emphasize on when to use them in a detailed manner. From an InfoSec or more specifically cryptography security point of view, they can be understood by the examples below. For immutable data type, think of it like you take a piece of A4 paper, you can give info to it either by using pen or to write data on it, or use printer to do it. When you do want to change information, you can do it in two different ways. The first way is you flip to the other side of the paper and then you write or print info onto it. The second way is you use some sort of correction tape on the specific part of written paper or printed paper. Then you write info on it. In either one of these cases, a question needs to be asked. Did the info truly change, or we just use new piece of paper or space and write information on it? The thing is, the old information never deleted or changed, unless it was being put into paper shredder or recycled. Before such an action was enacted, the info resides on different spaces. It can be seen by colleagues or other people. From a sensitivity or security point of view, this is not ideal. If from programming point of view, every action like flipping to the other side of newspaper or use correction tape is essentially creating new memory address and bind info to it, then return the new memory address along with new bound data to dev or programmer. Some examples are as follow. Mutable data type refer to the combination use of blank paper, pencil, and eraser. It is considered the exact opposite of immutable data types. If we look at any cryptography library that is open source, we can clearly see that all cryptographic operations are done in pointers or arrays. However, if we look closely, the mutable data type in C or C++ that we seen the most consists of void star pointer, uint underscore egg pointer, unsigned char pointer. In C# or Java, they have pointer data type an appropriate array. I'm not sure on Java, but on C# it is int pointer or uint pointer and byte or byte. To use cryptography library to maximum security, strict mutable data type need to be used, as these libraries to consist of functions to effectively override a given memory address with 0 without producing any immutable data type in the process. In such a regard, we can completely see PHP programming language is completely out by default. I'm not sure on other languages, but I do think Java, C#, Rust, C, and C++ to able to support or provide such function. If you look at password, passphrase, certificate, private, and public key, they are all stored in immutable data types such as string. Clipboard data attacks refer to when we copy some data, it temporarily exists in one memory called clipboard. Anyone able to access such memory will be able to disclose sensitive data if there is any. Hardware security module is actually something against the concept of open source or cryptography. The problem it aims to solve consists of credentials handling, zero trust on device or environment, mutable and immutable data type handling, and not supporting of certain cryptographic operations. Open source or cryptography relies on the concept of security without obscurity. Kirchhoff's principle. A system should remain secure even if everything but the key is public. Everyone knows how it works, thus proving both of its transparency and security. Security with obscurity refers to something works along the line of video games, anti-cheat and cheat. In security, it is anti-malware and malware. In hardware such as computer chips, graphic cards and hard disks or SSDs, it is DRM. Let us start with credentials handling. The best example is how can we store the password of a password securely. The password is not user's password, it is software own password. To make it easier to understand, we can assume the password as SQL credentials. How can we store the credentials in a way that the software able to access the credentials and do CRD operations while inaccessible to rogue parties? The first way is hard-coding it into source code. We essentially see this in all applications or software that uses SQL databases. It does not matter it is MySQL or NoSQL or MS SQL. Hard coding is okay as the server side needs to run only compiled software. However, such a reverse engineering protection is not possible on default PHP and JavaScript. This is because PHP and JavaScript runs on source code but not compiled software. The second way relies on storing the credentials as a file on server side. The app or software just load the credentials from the file. The third way relies on something like storing the credentials on memory, and it is considered secure if we look at files root access and reverse engineered source code root access. There's no visible example on this, but among all the three common methods, the last method is the most secure in the context of HSM. While there are other methods, but I believe their cores will not be too far away from these three methods. In terms of accessibility, the first two methods are the most accessible and feasible for all programming languages. The CA prototype application that I created mostly based on combinations of first and third method. Zero trust on device or environment is considered as something a lot more complex. I'm not sure if I know it correctly. Let us start with client's device. Is the file system on the client's device like if we are on Windows? It is any files or folders within C or D. If we are on Linux or Mac OS, it is any files or folders within directory 1. Are they considered trustworthy? If they are not, the safest place might be on the client's memory, as the secret keys or private keys or credentials do not expose in the file system. But again, the question comes, how can we load the private keys or secret keys into the memory in a zero trust manner? Now we go to a server side. Similar questions can be asked. If it is on browser or website, how can we ensure browser do not get to know our private keys or secret? Again, these visible issues or more complex issues are hard to be answered. AES, while a gold standard, it is incredibly easy to mess up in terms of security. The best choice for secure AES is to have specific hardware created for its use. We actually see this in LeapSodium's hardware speed-up version of AES 256 GCM. However, not all client devices have the specified computer chips or processors to be able to run that. Combining all of these issues, HSM primarily solve these issues by hardware-level security or something even more sophisticated. However, in terms of cost and the likes, not many want to buy a very expensive piece of HSM just to solve these issues. They can focus more on buying physical servers or more storage or more computers or laptops or mobile phones. Even if budgets were allocated, there could be a historical incident like the US cryptography's exportation limitation or banning law could be applied. Current Let's Encrypt does rely on sponsorship funding. It can be used for company internal network communication or external network communication. However, with the current funding structure, it is inherently prone to weaknesses. When it has no more funding and the work becomes too big or huge, then the users or companies that use its services will be insecure in an instant. This service shutdown may be temporary or permanent. While there may have a lot of ways to solve this, here are some of the ways that I can think of. The first way is to include some sort of monetization effort by embedding Ethereum wallet for node operator and the authorized users on that node. As of now, this way is okay as the wallet address is considered to be publicly disclosable and might not trigger GDPR kind of regulation. The second way is to include some sort of monetization effort by paying the node operator and the authorized users on that node by fiat currency or their nation's currency. However, this way may be prone to GDPR or some sort of law punishment if the information did not get secured properly. I can't think of too far as of now. This is as far as I can go. As of now, client-side did not incorporate software HSM, but server-side did incorporate simplest form of HSM. Both the client-side and server-side did strictly use mutable data types for secure cryptographic operations. It may be easier to create and develop software HSM for server-side compared to client-side. If the client-side needs to incorporate software HSM, we'll need real problem statement in order to be able to accomplish or do a minimum viable product for client-side HSM. As of now, node operators and users, be it authorized or end users, to provide such a mechanism in the applications that will be shown later. However, the mechanism may or may not be fully finished. Minimally using it to verify with each other is possible as CRM with digital signature as its prompt is done. Functions such as creating challenge, signing and verifying challenge are available for use. This is a proposed solution, but as of now, I'm not that certain on how to create developer APIs and modules. One of the possible way is via console or command line applications. The other possible way is via developer control or user control server and perform secure cryptographic operations there. Either way or other ways may need further assistance in doing or finishing them, allowing the user side able to log in and sign or verify the data or files with digital signature will be the main priority, as the browser can't really act as a man in the middle on the files or data. Having the ability to both log in and sign or verify data or files on both client device and website will be a good start. However, this will be based on pseudo concept on website side and root concept on client side. Regarding encrypting and decrypting data, pseudo concept will be only available for developer. The digital signature operations will be the first priority and needs to see whether it is feasible in developing APIs. The encryption and decryption operations will be follow suit, but it will not be available in browser or website as it contains the plain text data or files which may be not okay to be disclosed. The best it will be is in the form of APIs. Due to my limitations, the application created will be in the form of the API application and desktop application. Current CA prototype does make some modifications on this picture shown below. It was turned into the following. Its internal structure has at least 2 authorized users per node. The node will be having pseudo privilege and sign other nodes authorized users. This signing is performing operations on its authorized users' behalf. However, just like the Tor deep web, having too many authorized users within the same node could slow down the operations while not increasing in security. I will believe 2 or 3 authorized users will be sufficient per node. Currently, only the same level able to produce a certificate for each other. This applies to top level nodes. For secondary node, it can retrieve its signed authorized users certificate from top level node. However, if the end user would want to have certificate, only the current node authorized users signed certificate will be given to the end user. Full chain of trust functionality is not fully supported at the moment. With such a structure, it is inherently using web of trust. For minimal use or using it as a prototype is sufficient for both users and companies, but if stability is a concern, then perhaps a full stable version will be required. The first HSM roadmap will need to be done to an extent before this can proceed. This CA separated encryption and digital signature. The operations on CA is mainly digital signature. Encryption operations will have other client-side applications to be used. If the infrastructure was to deploy for external use, or in other words available in a public manner, the decentralized nodes need to have some sort of consensus or verification protocol. This will help to reduce the potential rogue nodes and potentially authorized users in behaving not in users' interest. However, what is the consensus protocol? I'm not entirely sure as of now. In situations where private CA was preferred, the consensus protocol can be served as some sort of optional hybrid to have slightly more secure private CA. The cryptographic protocol for end-to-end encryption is ×3 Diffie-Hellman, but there is some slight changes. You can refer below. The encryption part of the CA always enforces domain separation. One secret key will be used for encryption while the other used for MSE purposes. As of now, I can't say anything to my CA when it goes public. However, I will notify if I understand it thoroughly. The CA full stack application is an ASP.NET Core web API running on Linux or Ubuntu. The client-side application can be run natively with Windows user interface on Windows and Linux operating system. The client-side application has not been fully tested on Linux operating system. The application tries to enforce zero trust by using concepts only I know and tech stacks that are open source. That's all, and thank you.